Jeg kommer vadende ned i Istegade med min cykel i den ene hånd og en rigtig væmmelig hilsen fra politiet.
The problem with it is that this thing actually doesn't have a meaning, but I'll give you an explanation and see whether you agree or disagree. But it has to do with what's the meaning of freedom. I mean, that's the thing that was invariant under dynamics was a periodic orbit. It wasn't the points on periodic orbit. And even the notion of time was not sacred. You could have redefined the time, multiplied by some combination coordinates, and you still have the same periodic orbit. It's just that you would be putting different ticks on it in your different time units. And the same is true of all the solutions. So what's important about all these solutions is that they are invariant sets. But how you wander around them is up to you, as long as you're within the set. I'll write this in Danish. It should. Our freedom is that we can redefine the coordinates any way we wish, because you said we can do things like start someplace, redefine coordinates, and that was the same as going from there using translational freedom to get to the endpoint, and that's the same. And this statement is true any place at any time. Locally in space, it was that we, at time x, is the same thing as going someplace and coming back. The law doesn't change. This is the time evolution, infinitesimal time. And then there was, for me, incomprehensible, most elegant statement, which is Lie algebra, Lie derivative statement, so I won't say it again. And you have to understand, you're free to do this anytime. And it doesn't matter how you do it, because you're free to do it anytime. You can be very perverse and you can decide you do this by you go 1 millisecond and then you move 1 mile away and then go 1 millisecond, come back. The result should not matter because the translational motion can be anything you want. So we'll be a little bit, in the two examples I'll work out, we'll be gentler and we'll just say that what we can do is my trajectory in my rules of the game, I'm changing this to little t because I'll be using group tangents a lot and they're also little t's. So this is related to my representative. We'll call it a template because visually it makes some sense, but it could be, if you're a fancy kind of person, it could be called base manifold or whatever. The group orbit will be called, for people who know more geometry than I know, group orbit is fiber. And all my points plus their group orbit is called fiber bundle, if it makes you happy. And at any time, I can use a different rule. So this g tau can change. And I can relate this to a trajectory. Only thing that we require is that all the successive points of trajectory visit the same group orbits, but doesn't care where it visits. So that's the freedom we have. And the obvious way of using this freedom is to maximize my personal comfort. But I can put it in a different way. Suppose a swimmer is swimming from Florida to Cuba. So the swimmer swims, and the swimmer is in a shark cage, but she's not cheating because she doesn't get any propulsion from the shark cage. So this is like the famous elevators of general relativity. And the people who are pulling the shark cage along know very well the mean velocity of the swimmer, because swimmer is repeating its motion exactly the same every cycle of every stroke is exactly the same, so the mean velocity per stroke is the same. So this thing is moving, and if I'm a swimmer, I'm very happy because the shark cage is around me at all times. I'm moving, my head is where my head is, my hands are headed, and my world is where it is. I'm in this thing. So that's called the co-moving frame. But if I'm reporting, a naval battle with ships going or something, or there is a bunch of swimmers in the ocean, this shark cage is not terribly useful. The ocean, it's infinite, flat, etc. And there is one swimmer moving this way and moving this way and moving this way. And someplace else there is a swimmer which is exactly the same, strength, skill, speed and everything. But she's moving this way, this way, this way, this way. And they could be moving in spirals or circles or God knows what they could be doing, complicated things. So if I go to co-moving frame of this one, it doesn't really help me to understand what's going on with the other ones. Co-moving frames are not very helpful when I'm trying to figure out what 20 other people are doing, and they're all moving in different ways. So what you do is you study this in a lab frame, but it's going to be a little bit smarter than that. So lab frame is that you have satellites that look down and you get the picture, a Google picture, and things are moving on that picture. But that's actually not smart enough yet. What we really care about is we would like to compare this swimmer and this swimmer, see whether this stroke is better, what's going on. And it's inconvenient if they're all moving in various ways. But what we can do is, for each one of them, we can fix our camera so it's focused on the center of mass of the swimmer. So I take 7 cameras and I'm looking at this one, looking at that one, looking at the same time. And I know how to relay them because I know how much I have to shift each camera. We'll just call it a moving frame. All of these changes of coordinates. So this notion also has a very good pedigree. It was introduced by Elie Cartan in the 30s, late 20s, early 30s. Not thinking about dynamics, but thinking about how spaces are stratified by group theory. And he realized, and that's totally obvious to physicists, that you always choose the frame that's most convenient for your calculation. And usually it's a moving frame. It's a thing that moves in time. Now, we are moving in time, but we're pretending that our frame is there. There is another option. In mathematics, there is a tradition, I've traced it back to the 50s to call this a slice. The idea of that will be that what you do is you have all these different solutions, but every one of them you move into your frame using your freedom to do that. So somebody's doing something weird in the corner room, I bring them here and let them do it in a way that enables me to compare many different behaviors.